I see
Thank you.
John still online. Welcome,
Hi.
John.
Thank
John
you,
has
Howard.
been has been a loyal supporter of the workshop at Bonny Doon, but in a different capacity. He was an investor for many years, coming um, to our event, and now he's an internal startup. John was heading up the venture investment arm of Hyundai, and now he's decided that he wants to do something fresh and new, and so Hyundai is supporting him in creating a new vehicle startup, not a typical vehicle startup, but a vehicle startup within Hyundai, which is so interesting that I'm not going to try to describe it and let John describe it, but it is a different vehicle, shall we say. Um, hey, Alberto, if you could turn off your camera, that'd be great. Um, so, John, when are you going to take it over?
Sure. Thank you, Howard, and hello, everybody. And thank you for attending the conference here. As Howard said, I moved on to a new team, which is called New Horizon Studio. And what I want to do today is to share with you, I would say, a journey in progress, because this team is less than a year old. We started about a year ago during the start of the pandemic, and caused some delays, but we've made some progress, and I'm really excited to share with you some of the things. Some of you may have seen these on video and so on. But the subtitle here is being, to our journey in progress to reimagine mobility. And really, in a lot of ways, it's really about our imagination. How do we imagine what the future could look like and could be? And so what I want to do is kind of step through in this presentation, just kind of a series of thoughts, and there are no particular order. I did try to make it chronological, so here we go. So it really began with a question, and that question is here. What if a car had legs and could walk, right? And from that kind of question, you get a series of other questions from how would you do this? Who would need it? Where would it work? What technologies are important for this to happen? And so on, right? And these questions are continuing. These are just the first few that kind of came across as we were thinking about this. And as we, naturally, you might say, well, who else might have done this? And it turns out a lot of people have done this, and they've been thinking about this for quite some time, maybe as far back as early human history, thinking about how to make a toy horse, right? And making the horse four-legged machines have been in the mind of humans for a very long time, and we have some pictures here of some instances of that. Looks like you have a mechanical horse. Looks like there's a larger industrial. It's sort of the black and white picture to center. Certainly, bipeds have had their fair share of things. There's really companies like, among others, Boston Dynamics, which really have heavily, advanced the development of a quadruped. But not just that, you have even in construction equipment. I thought that I guess a backhoe of sorts with the combination of a folding leg, but otherwise it would travel on wheels is quite clever. And then you have, of course, science fiction, right? And it's hard to maybe not see some fantastic machines in science fiction, almost by definition, right? And here's some artwork from a Star Wars vehicle. But more than that, you might say, well, what about legs on cars? And it turns out that there are, wheels are actually fantastic, right? And wheels are incredibly provide an amazing amount of mobility until it can't. And it turns out there are certainly extreme cases, some of which are shown here. And sometimes people do that intentionally, but sometimes unintentionally. We kind of misjudge the surface or the depth of an area, but certainly there are extreme things. There are some things you might do something stupid, maybe, and I don't know if it's really if that Jeep in the lower corner there is really stuck, but people are certainly having a fun time watching that Jeep do something with that snow pile, which otherwise is a fine day. And so it turns out that, except for maybe the car that's in the lower left, they're pretty much operable, right? And it just needs a helping hand, if you will, or legs to get it out and unstuck. So the utility of robotic legs really provides greater freedom for legs. And so that led us to what we call the Cars with Legs project. And this is, we haven't really talked about it publicly too much, but what this are some concepts about the utility and where we might find some use for cars with legs. And so here's an illustration of a disaster area where you have a washed out area, there's debris, there is no maybe a clear road surface, and yet you might want to get to someplace to, in this case, rescue or to recover something in a disaster area. And we continued along this line, and as we thought on this journey, if you will, the idea of universal design came up, relatively early on. And universal design, as you may know, is this idea of how do you design things that are applicable to the extremes, right? And a good example is the curb cut. And you've probably seen a lot of these around. You're like, why are they destroying a perfectly good curb, in my neighborhood? Well, turns out it's part of the American Disabilities Act, right? And it was given a chance for wheelchair users to make it easier for them to navigate curbs, which for able-bodied walkers is no big deal, right? But if you're in a wheelchair, it is a big deal. Now, it turns out there are other things that benefit from this. And it turns out it's maybe some startups that some of you may be working on, and it's all of these sidewalk delivery robots, right? For those vehicles, it is great because they don't have legs and they can't go over the curb, and they have even harder time going up a curb. And you have sidewalk robots that have benefited from what is, for the American Disabilities Act, meant for humans. But hey, what's good for humans is good for robots too, right? And the arrow on the lower corner there is, you see the little knobby thing on the ground, which kind of signifies where you can safely cross. And so we took that idea as well. So in this picture, we're saying, you know what, let's design a car so that it's applicable to a broader range, if you will, of users. In this case, those that are using wheelchair, that instead of having to modify the car post-production, the car is designed pre-production in the design phase to be something compatible with a wheelchair user. And that's an idea that we took forward, looking at not only, of course, wheelchair users, but people on stretchers, carrying in a cart, having access on the side or the rear, and that sort of thing. And so that idea we kind of carried forward and into a concept which we call Elevate. And this is what we released in 2019 at CES. And this is a picture. And there's a lot of videos about this, so I'm not going to talk too much about Elevate in particular. One thing I will say, though, that we do call them this term UMV, or ultimate mobility vehicle, that we like to, well, at least my team and I have been calling that, is a new class of vehicle, right? This ability to walk as well as walk and roll, kind of a way of thinking about it. And so what we also did, so that picture is obviously concept, CAD drawing. We took the time to think about, well, let's put something together that emulates this. And we came up with a 1/8, maybe a 1/9 scale model using hobby scale motors and so on. And we also had videos about this as well. And this gave us more ideas, right? As we go, oh, well, this is interesting. Maybe we thought, well, this is not that much smaller or similar in scale to a sidewalk robot. And we thought, well, maybe uncrewed or unmanned or cargo carrying applications, specifically designed for cargo carrying applications, could be really interesting. And so that's how we came up with that was the origin or genesis of Tiger X1, which about a month ago we released a video, and we had a virtual press conference about this and more pictures about what is Tiger X1. And here's again, there's a lot of content about it, so I won't talk too much about it, except as show a pretty picture of I think it's a pretty picture, right, of a use case where it is in the outdoors, it's doing survey work, it is perhaps doing surface research through sensing and observation kind of applications. All right. Then as we thought about that, then we said, hey, if this vehicle is going into remote, inaccessible, hard to reach places, and how is it going to get there? And we thought, well, maybe what is needed is a way to transport it by the air. So we came up with this 2-vehicle hybrid system, which is also in the video. And here's a screenshot of that. We call it, the UAV, UMV, 2-vehicle hybrid mobility system, which is a long phrase, but it's maybe the picture is a better way of explaining it, where right, you have a place where there are no roads, or the roads are not good, and then you want to get to a place. The UAV carries the UMV, in this case Tiger, to a location, drops it off. Tiger does a mission, and it meets up with wherever the UAV is, or maybe they communicate with each other autonomously, and then it goes to the next location, or back to base, and so on. And it's really this smaller scale which makes this possible, right? And a larger vehicle like Elevate, I think, would be very well possible, but it's more difficult to do. But a lower scale, like Tiger X1, I think it is a real possibility. Moving on, we thought, well, you know, if we have autonomous or semi-autonomous operation, then we're going to want to have some kind of computer vision of some sorts. But these vehicles are moving a lot, right? They are in rugged areas. This vehicle has a need to operate with resource constraint, computing and power. So we came up with this idea of using computer vision, but using it in a wider baseline, wider than what you find in a typical car, ones that can be placed arbitrarily wide. And so we came up, we've been doing some research with a company called Nodar. And so this is the startup part of me coming out, where I've really become accustomed to interacting with startups, right? And maybe this is atypical of your typical engineering person or startup, where startups don't typically, well, they do, but they reach out to other startups, but I have I guess the luxury of reaching out to startups and working with them, and Nodar is one of them. We're doing some really great work on looking at a stereo camera that is built for off-road applications, and we've done some early work to show that yes, indeed, that an off-road design, for off-road use on in this case, it was a mountain bike that we got this data from, that can collect the data that we need to create a 3D depth map. So we're continuing to work with this company, really great company, by the way. If you're an investor, I would definitely check them out. Okay. Then we said, you know what, if we have a chance to rethink mobility, reimagine mobility, then let's rethink the manufacturing of that mobility. And so additive has been around for a very long time, obviously, and it's been fun to really explore what is possible with additive. And so here's a picture of Tiger with the body removed. And again, Tiger is doesn't look like a skateboard, but is in fact a skateboard platform, like a bunch of other EV startups out there. So it's identical to that concept. There's no difference between what you're seeing here and, say, whatever skateboard startups are out there. Same concept, right? Body on top of chassis in this case, but on top of legs. So anyway, we've been looking at various, I would call it desktop scale manufacturing. So we can do that because Tiger is a smaller vehicle. If we get to larger vehicles, we're gonna have to rethink how we do it additive, but we intend to use it because it has a lot of advantages. In this case, it's showing some pictures of what we've been doing so far. We've been developing leg segments, using Mark Forged, a half chassis you see there with a company called Big Rep. And by the names, they suggest that they can produce larger formats and so on. We've also looked into printing the tire as well as the wheel. Now, ultimately, what we end up doing in production will be very different, I'm sure, right? But this is a chance to explore these things. And as you do additive manufacturing, you can do other things like generative design, which is, in a sentence, I would say, giving you different ways of solving a structural engineering problem. And then topology optimization would be giving you a specific answer to one of the options that was created by generative design. Now, in fact, the two are highly related. One can argue that topology optimization and generative are one and the same, or maybe topology optimization is a subset of generative. Whatever the case may be, I'm just trying to step you through some of the thinking that we're going through. And again, thinking about startups where we've been, we've got some, licenses to Topology. This is a picture of one of the things that they've made, again, to take the output from generative design and to take one of those designs and then to really optimize it from a lightweighting viewpoint. Because for our vehicles, Tiger and Elevate and so on, weight, mass are absolutely critical. We cannot have a 3,000 or even a 2,000 pound machine, probably something lighter. All right, we've been computing is a really big deal. So we're doing computing in the cloud, working with a company called Rescale. Really quickly, fantastic company. Check them out. And then finally, I'm gonna zip through these last few slides here. But the thing that the one I'm really looking into lightweight, sustainable composites. So composites, carbon fiber is a great material, but it has to have a recycling problem, right? How do you get rid of the material that's pretty inert in a lot of ways? So the answer is one of the answers could be bioresins, right? And this has been a kind of a growing activity in technology. Combine that with plant-based fiber, right? Fiber has been used in composites before, but the long fibers that can replace carbon fiber, right? When you combine the two, you get something like this, which is a lightweight, sustainable composite that's made out of essentially plants, right? So here's to those that are into plant-based meat, then you get plant-based cars, I guess, right? So one day, and a company called Biocomp is developing, in this case, fiber, right, that has these great qualities, and among them a low CO2 footprint. So this is just at the very beginning of this stage of work. Now, finally, I want to look at applications, and one of them is Wildfire, and Howard certainly knows this very well. This is actually a picture from the CZU fire complex just 7 months ago, right? From August to September last year, it's horrible fire, destroyed 7,000 structures. I think Howard's place has been spared, but his neighbors, I think, tells me we're not so lucky, right? And this is a growing problem, right? We have a growing problem of fires in the West. In this case, this picture showing California, Oregon, and Washington trending higher. And it's really, many believe it's global climate change that is altering the local weather patterns, and those local weather patterns, as they change, produce a lot more fuel. When you have dry lightning strikes that we had last August, and you have a firebomb, right? And it was a horrible year. And it seems like every year it seems to be bad. This year, who knows? But we have to be ready. So the thing that it's interesting is that the fire crews that are out there, they're fighting it with the technology is this, right? You got an axe, chainsaw, shovel, and an axe, okay? That's their technology to fight the fire. Now, good tools, right? You don't want to replace what's already a good tool, but the question is, what else can be done to help these crews out there fighting these pretty massive fires for weeks, sometimes months on end? And then kind of closing up here, I'll kind of look at Lunar Exploration. It was almost over 50 years ago, or about 50 years ago, actually. It was the summer of 1971 where this vehicle landed on the moon, Apollo 15. That was the last time we had any kind of car on the moon. So hopefully we can look at that. And many reasons to go back to the moon, among them resources. And in this case, among others, is the South Polar region, where there has been the discovery of water. And water can be used not just for drinking, but can be used to separate oxygen and hydrogen, both of which are fuels for rockets. And that fuel then can be used to power other missions to places like Mars or what have you. Anyway, there's a lot of interesting minerals on there, and among them helium-3, which one day could be useful for fusion if we ever get to that. If there's a startup out there, right, that's going to do
John,
that.
so
yeah,
we're about to run out of time, but I can't not ask you a burning question. So apart from the applications in the background and the technology, which is all incredibly interesting, maybe you could say a few words about how you fit into a large corporation as a startup, how it came to be, and how you are supported, and how do they measure your performance? I mean, what are the metrics?
So I fit what I would say within a very kind of very unique and special place within the company that is looking at these kind of outlier ideas, but could one day feed into the larger initiative of new types of mobility, and among them include aircraft and robotics at large, right? Everything from industrial automation through personal robotics. And so my team is not quite fitting into either, but it is part of that larger initiative that management is really supporting to explore new things. And so how I'm measured by success is, I would say, right now it's probably generating IP in support of those ideas, and then number two would be creating some, I would say thought ideas that would have not otherwise been thought of if we were doing conventional things, right? It's literally kind of just that, just like what are new ideas out there. Ultimately, though, is product, right? Ultimately, the end of the game is to make product that we sell and create a new market with future customers.
Terrific. Well, it's extremely farsighted and innovative for your company to be doing this and supporting youth. And thank you for sharing that all with us, John. It's terrific.
You're welcome. Thanks a lot. And it was pretty fast, but it's great sharing with you.
Terrific.